The next coming lectures are part of the advanced topics. So now you have covered all of the Kubernetes basics, and now we're going to start with advanced topics. The first topic is service discovery using DNS. As of Kubernetes 1.3, DNS is a built-in service launched automatically using the add-on manager. Before 1.3, you had to enter some commands. Now it is already launched automatically. The add-ons in Kubernetes are in the etc Kubernetes add-ons directory on the master node. You might want to take a look there if you are interested in other add-ons. The DNS service can be used within pods to find other services running on the same cluster. Multiple containers within one pod don't need this service, as they can contact each other directly. A container in the same pod can connect to the port of the other container directly using localhost port. So if you have a web service and a database service, then the web service can just connect localhost and then the port of the database, and it will be able to access the database within the same pod. If you want to connect from a web service in one pod to a database in another pod, then you need service discovery, because you cannot just access this other pod. You don't know the IP address or port. To make DNS work, a pod will always need a service definition. So only when you create a service for a pod, then the pod really becomes accessible and service discovery will work. So this is an example of how one app could reach another app using DNS. So on the left we have application 1, we have a container in a pod and a service for that pod. The service is app1 and has IP address 10.0.0.1. Then on the right we have application 2. We also have a container in a pod, and this has another IP address. It has IP address 10.0.0.2 for service app2. If you would execute commands on the container of pod 1, for instance host app1 service, the name of the service, then you would get the IP address back 10.0.0.1. This is the service discovery in action. You only need the name of the service to find the IP address of that service. If app1 wants to contact app2, it can do a DNS lookup on app2-service and it will get IP address 10.0.0.2. This is only going to work if both applications are in the same namespace. The standard namespace that we have been launching in is the default namespace, because we haven't really specified a namespace. What does it mean? Default stands for the default namespace. Pods and services can be launched in different namespaces to logically separate your cluster. You can have different namespaces just to logically separate your cluster. Default is a default one. There's also kube system, where the Kubernetes services run in. If you would want to specify a namespace, then you just do a DNS lookup of app2 service.default, where default is a namespace. If you want to do a lookup on the full hostname, the full hostname is actually the name of the service dot the namespace dot svc for service dot cluster dot local, and this whole hostname also resolves to 10.0.0.2. This is how one application in one pod can access another application in another pod. These requests here are always on the A type, which is resolving from a host to an IP address. There's also an SRV type if you want to know the port number. So here we just have the IP address, but it's also possible to get the port number. So how does it really work? How does this DNS really work? So let's say that we have a pod. See pod 1 on the left with a container. We can start this container using kubectl run busybox. We're going to run the image busybox, which is just going to give us a shell. And if you use cat to show the contents of a file, here we want to show the contents of etc resolve.conf, then you can see that the name server points to 10.0.0.10, which is the DNS server. And the DNS server is kubedns running in another pod, exposed as a service with IP address 10.0.0.10. And the reason why you didn't see it when you did kubectl get pods is because it runs in another namespace. If you would do -- namespace equals kube system, when you do kube control get pods, you would see that there are pods running anytime when Kubernetes is running. The reason then why we can use the service name or service name.default or service name.svc.cluster.local, you can see here in the line with search. In Linux, when you look up a DNS name, this can be automatically added. So it will, if you just do a lookup of the service name, then actually it will do a DNS request of service name.default svc cluster.local. So this is how it works under the hood. DNS resolving can help you to do service discovery. In the next demo, I'm going to run a deployment, which is a web app, and I'm going to run a separate service. And then you will see that just using DNS names, our web app will be able to find the database, which is the other service. That's for the next demo. So you can just continue with next lecture, which is the demo.